Hello friends, konnichiwa. My name is Aisman Samasi and welcome to day 2 of the machine learning bootcamp for our comment category prediction. Okay, this video will cover all about text pre-processing, TF-IDF vectorization, column transformer, and making an end-to-end pipeline for your dataset. Okay, so this video will be very much helpful for the text pre-processing part and also to make the full pipeline for your project. Okay, so in our last video we talk about the whole pre-processing part. In this part we will be only seeing about TF-IDF vectorizer for our text and using column transformer and pipeline here. Okay, also like if your pre-processing don't require any human text or the comment here, you could skip my video to part B of our column transformer. Okay, so we'll be going with our text pre-processing first here. Okay, on where and how to process our human text for our natural language processing. So let's start with how computer or machine understand human text. As always, computer will not directly understand strings here. Okay, we need to convert to numbers for machines to understand. Okay, now the main point here is how will the word be then vectorized to numbers here. Okay, here is the main point and that is where the vectorizer took part here. Okay, so basically we have here whole text here and we have to change it to machines here. Okay, you will see here that there are various parts in the vocabulary. We first start with cleaning our text, then we tokenize, then we vectorize, and then we finally pass on to our model here. Okay, so the whole text pre-processing is only these three part here. Okay, so like I love machine learning isn't text here. We will first clean it into our lowercase and we will be removing emojis, etc. Then we tokenize it into love machine learning, etc. We would skip I and then we finally vectorize into numbers to get the machine to understand our code here. Okay, and over the period of time when model will learn this, model will eventually learn that the word I which correspond to 1 here is more prevalent in good emotion, and that will be how the machine will be learning the whole emotion part here. Okay, from our text. Then we have our vectorization basics, where it is a way of converting text into numerical vectors so machine learning model can process it. So it is by this vectorization basics we could convert our text into numbers. Okay, so we go from text to tokens, then we move on to our numbers, and finally vectors with which the machine will learn. Okay, each word becomes a number and a sentence become a vector here for our machine learning part, and this is the whole basics of our vectorization in one part. Now here after each word becomes a vector in high dimensional space, it could easily span 200 dimensional or even 300 dimensional vectors here. Okay, for big models it's even more than that. Then we have types of vectorization, like we have our first is TF-IDF vectorization, which is used in our classical machine learning from our sklearn, which basically reduces importance of common words, where basically models learn the importance of words to correctly classify into positive or negative, and with the amount of time it could easily classify into 0 and 1 here. Okay, so you will see here that I have here the YouTube statistics data, where we have the comment and we have the sentiment here. Okay, so when I will passing it to TF-IDF vector, it will basically learn the words that are corresponding to class 0 or 1. Okay, so in this way the whole pre-processing of text works here. Here the TF-IDF don't actually understand the whole sentence, but it uses the importance of common words in our class 0 or 1 and it learned it. Okay, so in short it doesn't actually understand the text meaning here. Okay, and that's why here pre-processing is needed. Okay, then we have our word embeddings and our contextual embeddings, which is generally used for our deep learning models. Okay, here word embeddings, like our word to vectorization and glue here, basically captures the meaning, and here words with similar meaning get closed in vector space. Then we have contextual embeddings, which our NLP models like our GPT or BERT uses. Basically it understands the context of the whole sentence, and it very this state of the art in our natural language processing. Then we have here text pre-processing basics here. Okay, so first thing we do in our pre-processing is to lower our case here. Okay, So basically here the love with our L capital and small will give the same feature importance and reduce our vocabulary size. Okay, so here converting to lowercase will help us in lower vocabulary size. So basically here for this we basically def function that take a text and we convert into lowercase and then we return it. Okay, and then we change our comment column to string here to handle null values, and then we apply here our clean function. Okay, then we'll be when we'll be using our df.head, you could see here that the comments are now lowercase. Okay, I think here if I forget the return text here. Okay, when I will run it, you will see here that everything is now converted into lower case here. Okay, for our comment column here. Okay, so this is how we lower our case. Then we move on to remove our noise here. Okay, so in some comments here some noise exists, like our URLs here. We could remove the URLs to help us lower more our vocabulary. Okay, so we do it inside our this function only. We do it by importing our regular expression function, and then we run it, and you will be seeing here that there will be no links inside the comments here. Okay, we could use this as in pre-processing, where we find our HTTP and WWE to find and remove the hyperlinks here. Okay, so this is how we basically remove noise here. Okay, now we need to handle our emojis too. Also here our emojis do carry motion. Okay, so we will not be removing it, instead we will be converting it in using our import our emoji here, and here we de-emojize our text here. Okay, and then we return it. So we write here de-emojize, and then our comment will be free from all our emojis here. Okay, so this is how we handle emojis here. Then we could also reduce our repeating letters with this here. Okay, so without fixing, TF-IDF treat them as new words. So here we will be seeing that so good some user do type, and here we will be creating new vocabulary if we don't do it here. Okay, so we do it the same way. We use our regular expression function where we import our regular expression, remove the frequent used letters here. Okay, so when I will be returning, you will be seeing here that there will be no frequent letters here. Okay, repeated letters. And then finally we do lemmatization, which will basically convert word to base form. It is helpful in reducing dimension and keeping same meaning. Okay, so running becomes run, better becomes good, and cars become our car here. Okay, so by using this we are basically using the same meaning to understand the context of the sentence here. Okay, without it will be treated as new words here, and the models will not understand it. So we import our word net lemmatizer, and then I use my words to text the split, and then I lemmatize each one of the word, and then I return the words here. Okay, so here I'll be returning that, and by this our whole pre-processing for basic step will be completed here. Okay, also you could remove some special characters or some stop words from the pre-processed text here. Okay, and here finally you will see that we use our lemmatization to dissociate our whole text here. Okay, it is coming at least, but we'll be changing it. Okay, so now the main part is the TF-IDF Vectorizer. Okay, we get it from our sklearn feature extraction text, where basically we differentiate the whole words into numbers here, and then the whole sentence become our vectors here. Okay, we get from sklearn.feature extractor.text the TF-IDF Vectorizer. Then I import the code here, and here since I am getting as list here, I will be converting it into string here, and then I will be running the whole code, and you could see the shape here. Okay, so if you will clearly see the shape here, you will be seeing that the rows are the same here, only the columns are the different. Here the column represent the learn pattern here. Okay, so here the X is basically returning the sparse matrix here, and here the first row is same as the document row, and here the 3427 here represent the vocabulary size. Okay, so return the sparse matrix here, which is not a numpy array but is very memory efficient. Okay, that's why I written it. And then when you will be printing it, you will be seeing that it's an Skype matrix with the learned values here. Okay, so if there are 1000 documents and 5000 unique words it learned, then it will be returning our 10,000 and 5,000 respectively. Okay, so when we'll be running it, you will see that it now learned 34,000 words for us here. Okay, now we have the parameters which the TF-IDF Vectorizer takes here. Okay, so it first takes whether to lowercase the inputting string or not here. Okay, so if you are keeping it true, here the everything will be changed to lowercase here. Okay, so if you're not lowercase, earlier you could use this. Then we have our stop words as English, which basically remove the common words like the, is, am, are, of. Okay, it reduces noise and it is very helpful in sentimental tasks. Okay, but it may remove some useful words, so be careful for that. So here we remove the most common English words here for our English language here. Okay, by using our stop words equal to English here. So we could also put that here like stop words equals to English here, ENGLISH, to remove our most common English words here. Okay, then the next parameter is our max features. Okay, it is completely optional, or you could give it a limit here. Okay, basically it limits vocabulary size and it controls the dimensionality. It prevents overfitting. Okay, and if you will not set, if you will be using all words here. Okay, so here if you are using max features equals to, let's say 1000, you will see here that the learn pattern is 1000 here only. Okay, so this max features defines the limit of the learning behavior of our TF-IDF Vectorizer. Okay, if we use our 2000 here, you would see here 2000 learn patterns only here. Okay, so for our project I recommend to delete it from here. Okay, let the TF-IDF learn the best pattern for our project here. Then the next we have is the NP-gram range here. Okay, so we do it by n-gram range equals to 1,2 here. Okay, so basically here we pass is that we either pass n-gram range 1,1 or we pass our n-gram 1,2. Okay, so here n-gram image basically take each word once here. Okay, while our 1,2 take one word once and then two word once here. Okay, so if you have here a good movie, it will take a good movie, then a good, then good movie. Okay, so it basically take one word and then it could also take two word per sentence here. Okay, it is extremely helpful during our negations words here, like I don't like. Here basically it will take the don't like as common here. Okay, and you could take from 1 2 3 4 5 n number of times, but generally we use from 1 to 2 here. So when you will be running this, you will see that the learned matrix here has changed here significantly. Okay, so when you use your n-gram range 1,2, it learn more text size here. Okay, so here I write it for our n-gram 1 and 2 words. It has learned approximately 2,57,000 words here. Okay, approximately learned words here. So by using our n-gram features, we could learn more words for our range. Okay, then finally we have our mean difference and we have our max difference. Okay, these two basically determine to ignore the words that appear in less than n documents, or either ignore the words that appear in n percentage of the documents here. Okay, so here for our minimum difference, if we keep it to 2, so if the words that appear only on 2 documents, so we'll be not be learning it as it is in real world. For our max difference, if we are passing here as the 0 point float percentage here, it will be ignoring the words that appear in the percentage of that word here. Okay, so when we'll be using our minimum difference and the max difference, you couldn't see here that the size had also changed here. Okay, like slightly drop here. So here you could also make these two here hyperparameters, okay, minimum difference and max difference. Now it's time for our final part, which is how to use TF-IDF Vectorizer inside our model here, okay. So we, for the pre-processing, we use our function here like we had done here before, where basically it will take the text and do the all pre-processing part, and it will return it back using the function here, okay. So here we need to also make sure that the column is in string, so it will handle the null values here, and then we use apply function to apply our pre-processing. Then we use our vectorizer.feed.transform to basically transform our whole text here, okay. So we have our row CSV, we use our pre-processing function, then we use our TF-IDF vectorizer, and then we get our sparse matrix here, okay. And to join them we use our skype function. So we use our skype dot, just a second, skype dot sparse here, and we import our h stack to basically stack our columns here, okay. So we could use a stack here using this, or even better, we use our column transformer, okay, directly, which is our industry and professional level. So in our column transformer, it is basically a way to do parallel pre-processing here, okay. So we use our column transformer. So in the real data set, basically some columns are numerical, some are categorical, and so many different pre-processing path here, okay. So you will see here that my data have one categorical column, then an index column here which needed to be drawn, then a comment column, and then likes and sentiment here, okay. So what we do is that, if you'll see here, there are categorical types. You could see here that many are object, many are float, and many are int here, okay. When you will be using describe here, you will be seeing that the whole description of the data set here, okay. So if you will be seeing this here, you could easily identify that here the our likes columns need a scaling part here, okay. And for our comment part, it will need our text pre-processing here. So basically with the help of column transformer, we basically give a list of here processing block, where basically the transformer is applied to each columns of the data given, and here basically it takes three things. First is the name, then the transformer object, and finally the columns. And here each row represent and one pre-processing block here. So basically the format go from our top to bottom here, pre-processing each thing, okay. First thing you must remember that you must always split first, okay. You always do your train test split before using the column transformer, okay. Also we could check whether there is null exist or not. So we do here is df.null, and here you will see that there is no null value, so I will be skipping the handling null thing, okay. So for our train test split, we'll be importing train test split from our sklearn model selection. Then here the target is sentiment. So for x I will be dropping that target, and in y I will be using that target value. Then I will be using x train, y train, etc. for our x train split. And then I will be also be using stratify to handle class imbalance. Then here I will be making my sklearn.compose import column transformer, and here I'll be making a new variable named processor, which will be column transformer, and it will be transforming our x train and x state. I think I had wrong here, so this one is correct here, okay. So we have our id, which will be dropping here before our train test split. So it columns equal to this, and I will be also be dropping my video id, okay. So our column transformer will be working on this here, okay. So here I will be first passing the any string here name, and then I will be passing the function which needed to be done here, okay. So I will be using for numerical, I will be using standard scalar, and here I have to pass my numerical feature or the column name which need to be done here. So I make a new features. I will be passing here likes, which will be our num feature, and then our text feature, which is our comment here. So I will be passing our num feature. and then I will meshing the exact same rows here for our TF-IDF vectorizer. So I'll be passing the vectorizer function, and here I will be passing the text features here. Okay, here I'll be importing my sklearn.preprocessing, import our standard scalar here. Okay, so here it's transformers, just a second, it's transformer here. When I will run it, you will see that run is successful and everything is fine here. Okay, for our column transformer. So just a second, I add the comments here for train test split, then column transformer, and then finally the pipeline here. Okay, so what is the pipeline? So a pipeline is a structured way to run a sequence of data processing steps and model as a unified workflow here. So the old way of doing pre-processing is to first clean data, then do the vectorizer. In our last video, you have seen that we done the each data here one by one. Okay, but by using our pipeline, we could use our first the column transformer at once and then the model part. Okay, so here cleaning, transform, train, etc., everything will happen in the same line here. So here by introducing the pipeline, every data test go through the exactly the same test and the code becomes simpler and safer. Okay, it is an automated sequence of transformation and a model applied in order to data here. Okay, so data will come here, it will first pass through our transformer and then to the model path here. Okay, so pre-processing and our model will be done in one single unified workflow here. Okay, so we import our pipeline from a sklearn dot pipeline, import pipeline here. Okay, so here we declare ourselves pipe, and here we pass here two rows with first with our transformer, and second with the model we are going to use here. Okay, so we import logistic regression for our sklearn dot linear models here, and then inside the pipeline we pass here any string value here, and here we pass the model here. Okay, like this, and then we will use our pipe.feed in our x train and y train here. Okay, so you will be seeing that here the whole pipeline will work for our first here the column transformer, here the standard scalar needs a string here, and here finally you will see that the whole pipeline will work first with pre-processing using standard scalar and TF-IDF vectorization, then logistic regression. So basically by using our pipeline, we will be directly pre-processing our data and then running our whole model path here. Okay, so this is basically how the pipeline column transformer and how we basically pre-process our text data. Okay, so in this video we learn about TF-IDF Vectorizer, how to use column transformer, and how to make a whole pipeline. And I hope you learned something from my video. Okay, thank you and bye bye.